So thank you again for joining us and for sticking around to listen to how we can build using our IoT service and other AWS services alongside Amazon Echo to improve healthcare outcomes. Just a bit of an introduction to who I am. My name is Payne. I'm a solutions architect at AWS. I've been with Amazon for about 2.5 years in the solutions architect role, working with a whole range of organizations from early stage startups right up to sort of household name enterprises. I'm a generalist solutions architect, so I know quite a lot about all 70 odd services and yeah, can certainly give you a broad view of the platform. But today I'm going to be picking a handful of services that will be of particular interest for the topic we're looking at. So hopefully I'll be able to give you an idea of a general introduction to IoT. I appreciate for those familiar faces in the room who have been here all week. We've talked about IoT in a number of contexts. So I'll be trying to focus very much on how IoT is being used in healthcare and how it can be used in healthcare to accelerate your applications. I'm then going to go on to talk about what are the alternatives if you just want a platform to get going on? Are there tool sets or products that exist already that you can extend with your own healthcare capabilities to get the maximum outcome or the maximum benefit without building too much on the back end? And that's really where Alexa will come in. And I hope to use KidsMD as my example here. The folks from KidsMD actually spoke at re:Invent a couple of months ago, and the full session is available online. But I'll be using that as an example of building with Alexa to improve healthcare outcomes. And then the very last part of the deck is a little bit more technically focused, but hopefully it'll give you an idea of how easy it is to get going with Alexa and building Alexa skills, and what capabilities the Alexa platform has to make it easy for you to build those applications. Just as a show of hands, I did this yesterday as well, but who in the room would consider themselves technical? Okay, amazing. That's great. Sometimes there's a concern putting the technical slides towards the end because you end up losing half the audience. Within those, who would consider themselves developers or hackers? Amazing. So yeah, hopefully you'll be able to take the slides and take the Alexa Insider and actually go ahead and build a skill. It really takes no more than an afternoon. Sort of on day one when the Alexa service and the Alexa voice service was announced, I had my Raspberry Pi out, and honestly, it's an afternoon's work. But before that, let's dive straight into the IoT service. So first thing I'd like to note, and a huge thank you to Alistair for his talk and how they're using AWS services. One inconsistency, the Amazon IoT service is no longer in beta. It is generally available. That's only outdated by about a month. The announcement came sort of mid to late December, but the IoT service is generally available. You're able to pick it up to build applications today, and we have a number of customers already who are using the service in production. But what does the IoT service actually do? What is it designed to help with? Well, like most AWS building blocks, it removes the undifferentiated heavy lifting associated with IoT applications. It makes it easier to get going and deals with a lot of the sort of barrier to entry or the common tasks associated with managing IoT devices. And with most IoT apps, there are core concerns that you have to think about in your application. So how do we authenticate and authorize devices to chat to our gateway? How do we make sure that we're speaking to the right things and that those things aren't compromised? For that, we have mutual auth, certificate-based mutual auth that allows you to embed certificates in your devices. Mutual auth implies not only does the device have an identity, a certificate that we can check from our gateway, but also the gateway certificate allows the device to make sure that it's speaking to the right gateway. This is different to sort of single direction auth that you're probably familiar with web interfaces where you're just trying to check that you're speaking to the right person. Mutual auth actually goes both ways. And the IoT service allows you to generate these certificates just in time. So rather than having to sort of pre-generate for a batch of devices, you can generate that certificate and embed it in the device only when it comes to be registered. So it makes it very, very easy to get those certificates and to use that base level authentication. And then after authentication, we also support encrypted transfer protocols, encryption by default over MQTT or over HTTP. So security is really at the foundation of the connectivity between your devices and the IoT service. And given the healthcare theme this afternoon, I wanted to emphasize that security is baked in. And we make it very easy to achieve secure platforms using the IoT service. But once your devices are connected up to the gateway, there's a few other concerns that we would have. So registering our devices, keeping a list of all of the devices that are connected up to the platform, their responsibilities, their attributes. Using the device registry, we're able to keep track of those attributes of our devices. That might be serial numbers, it might be production runs or versions, it might be who their owner is, what accounts they're linked to. All of that can be stored in the device registry to be accessed by your applications and by the devices themselves. The next thing that we would be concerned of if we were building an IoT application is how do we deal with the messages coming from IoT devices? If you consider that we may be talking of billions of individual things in our Internet of Things context, all producing maybe real-time messages, producing time series data of what the current temperature is, or what the heart rate of the wearer is, or all of the metrics that we're interested from a healthcare perspective, how do you deal with those rules how do you deal with those messages and apply rules in real time? And that's really what the rules engine allows you to do. With the rules engine and an IoT service, you can write SQL-like statements to manipulate, to group, to direct messages to your back-end systems. And these might be existing web interfaces, existing event collection destinations, or it might be simply S3. If you wanted to collect all of the metrics as they arrive and put them into an object storage for long-term storage and maybe downstream analysis, we allow you to write those rules in a very, very simple format and for you to just let the rules engine get on with directing those messages. The final component is the device shadow. And this really speaks to the development focus of the IoT service. From a developer's perspective, if you want to interface with these IoT devices, considering that in a lot of cases they may not be always connected, rather than having to wait for a device to come online, have endless loops in your code, searching or scanning or waiting for devices, what the device shadow allows you to do is it gives you an endpoint to push desired state. So if we were controlling lights, for example, even if the light bulb or the destination thing isn't connected, we can write to the device shadow saying, I would like the lights to be on. And the next time the device is able to connect, it checks in with the shadow and downloads its desired state. So it gives you this programmatic interface for developers to interact with things in a synchronous manner that allows the things themselves to be asynchronously connected to. And so it makes it really, really powerful. You no longer have to handle those connectivity issues in your applications. You can do it directly through the device shadow. Great. So the IoT service goes a long way to making it easy for us to connect up IoT devices, to connect up smart devices. But there's a host of other services that we use on the back end to actually process that information, to work through and ultimately build an overall application. One of the ones I wanted to call out today was Kinesis. So one of the destinations for our rules engine might be a Kinesis stream. And what Kinesis allows us to do with minimal operational overhead is consume large quantities, terabytes per second or per hour of data, and to do with those messages as we would. Kinesis provides you the client library to consume them into your existing applications, or with integrations like Lambda, we can consume the messages from the stream and present them in a way that all you do is add your code. Kinesis is entirely managed by us. We allow you to scale your Kinesis streams in and out by adding shards, but ultimately you are not responsible for installing Kinesis on virtual machines or managing any of the underlying infrastructure. You determine how many shards you would like for a stream, and we do the rest. So it really takes a lot of the work out of these otherwise large processing systems. The next building block that we would look to be using in a system like this is DynamoDB. So DynamoDB is an internet-scale NoSQL database engine. And again, similar to Kinesis, DynamoDB is designed to be very easy to operate at scale and reduces your overall operational burden. So DynamoDB gives you a consistent single-digit millisecond latency connectivity to a database endpoint at scale. You don't have to worry about provisioning capacity in terms of storage. DynamoDB will grow in 10 gigabyte increments as you input data. For those of you who have managed databases in the past, that alone should be a reason to be looking into Dynamo. Scaling up databases can be tough, and DynamoDB takes a lot of the work out of it for you. The only thing you do have to determine for us is how many reads and writes per second you would like to your table, and the rest is handled by us. For those of you who are maybe new to NoSQL as a concept, NoSQL compared to a traditional relational database, which is commonly called SQL, is far more flexible. You don't need to determine the schemas beforehand, and it usually is for optimized use cases, where you know your access patterns ahead of time, and you don't need a general query interface like a SQL engine. You just need it to be highly performant and highly scalable. So for those use cases and for accessing this information at very, very or real-time speeds, DynamoDB is an obvious choice. And the third one I'd like us to have a look at is Lambda. We spoke a little bit about Lambda yesterday afternoon, and again, for those who have joined today, Lambda gives you a place on the AWS platform to determine your code and nothing else. The idea with Lambda is, again, you aren't responsible for managing EC2 instances or virtual machines. You aren't responsible for managing the underlying infrastructure and all of the tasks that go along with that. Things like patch management, security updates, provisioning capacity as you scale out. All of those responsibilities are for the Lambda service. What we provide is a place for you to specify your code. You also determine an event or a trigger that triggers that code, and that is it. The payment model with Lambda is per 100 milliseconds of execution. So one of the other major benefits, beyond the ease of use, the simplicity of deployment, and the scale, is that you're not paying for downtime. If functions are built down to the 100 millisecond level, the function runs when it needs to run, and when it's not running, you're not paying. So you completely remove idle time from your infrastructure, which makes the cost of the solution as cost-effective as possible. Actually, if your account is under a year old on our free tier, the first 1 million invocations of a Lambda function are free. And so you may not even break out of the free tier for your first year for a lot of use cases. And when you do break out of it, even at tens of millions of requests, it's dollars in terms of money spent. It's a really, really powerful platform. Allows developers to get going quickly, but without having to worry about what their application might look like at scale. Great. So how do we piece these together and make something that's actually useful? So I wanted to go through an example use case using our IoT service. So this is a medication status monitoring device, as an example. So a pill box that's dispensing pills at various times during the day and monitoring when they're actually taken out. We use our IoT service and the IoT SDK embedded on the device to authenticate with our IoT gateway and to pass the messages that correspond to the device statuses and activities. Those messages are public to an IoT topic. A rule collects those particular messages and pushes them onto Kinesis. The integration between Kinesis and Lambda allows us to consume those messages as they arrive and to react to them in near real time. And rather than, again, running a large capacity or a large pool of compute to deal with these messages, Lambda is executed as they arrive and takes the work out of retrieving those events and allows us an interface to write the functions to deal with those events and almost nothing else. And finally, we have DynamoDB on the back end to persist those for long term. So the idea here is that we want to write these status updates in Dynamo so that we can see the long-term responsibilities or statuses of the end device. And this allows us to persist and to keep a track record of when pills were dispensed, for example, or when statuses have changed with our end devices. And once they're stored in Dynamo, we then have an interface to query that information in web applications and mobile applications, to be able to show those activities as they happened, to be able to audit the pill dispensing workflows. And this would be fantastic for healthcare professionals who are, for example, dealing with patient care outside of a hospital. Once a patient has left, is on medication or is on, for example, antibiotics, it allows us to keep in touch or to monitor their health after they've left a hospital. This could also be used within the facilities. So again, healthcare professionals who are responsible for patients have an interface to check whether the regimes they've suggested are actually being followed. And what we'll also explore is how Alexa can be used to add a voice interface to that information. So having a mobile app or having a web page is one way to interface with the data, but increasingly we're seeing the adoption of new and innovative interfaces for this information and being able to interact with data, to be able to query it, to be able to get answers quickly without having to go to our phones and our computers. Great. The other example put up here is our simple notification service. For those of you who haven't come across SNS, SNS gives us a way to drive alerts based on these activities. So again, the idea here would be if a pill was missed, for example, that would be registered by our device saying, I opened but nobody took anything out. We would be able to catch that event, experience it, store it in DynamoDB, and from there send out notifications, whether that's text messages or mobile push notifications, to make sure that that activity is followed up on. So we heard a little bit this morning on strategies for remaining compliant in the cloud. And again, a few of the questions, Alistair did a sterling job answering all of the very difficult security questions and concerns from the audience. I wanted to add both Martin's session this morning on compliance strategies, but also my own voice. There are strategies for dealing with compliant data on the platform. For those of you familiar with AWS who have been monitoring our progress over time, you will have seen that last year, as an example, we released 600 new major features and services. In fact, it was over 600 by December. And given the pace of innovation at Amazon, we always gather feedback from our customers and iterate on those. And so when services arrive, particularly in the compliance space, usually compliance with certifications implies demonstrating competency over a period of time. So as newer services are announced, we work very quickly to bring them into scope for compliance, but because of that requirement to demonstrate compliance over a period of time, there can sometimes be a short delay. So how do we deal with that in our architectures? Rather than waiting for services to become available, there are strategies you can use to use the services that are currently in scope to build today on the platform, knowing that you'll be able to use that information to greater kind of benefit later on. So the example I'm using here is HIPAA compliance. So there's a set of services we have that are in scope for HIPAA. I appreciate that here in the UK that isn't directly relevant, but I wanted to present a strategy for remaining compliant in the cloud that can be applied to other compliance and regulatory requirements. So the idea here is that the events that we're pushing through the IoT service don't actually contain any personal health information. We have a need to store the user's name, their addresses, or any of the other confidential aspects of their care. All we're really recording is whether a particular drug was dispensed at a particular time. And what that allows us to do is store the actual relationships, the human information in systems that are designed to meet those compliance requirements, while still being able to integrate with the IoT service and Lambda and a number of others that aren't yet in scope for HIPAA compliance. And so from our monitoring device, we're using services like S3, going the other way, like S3 and EC2 to store and process that information, the personal health information that is bound by HIPAA compliance. I've included SQS here to demonstrate that when we upload objects to S3, that can generate notifications. And again, the notification itself contains no personal health information. All it is saying is that a new object has arrived in S3, in our object storage service, and it needs to be picked up from somewhere. And so clearly drawing the lines between what you consider personal health information and what is just notifications or general status updates that doesn't contain sensitive information allows you to extend the capabilities of your application without confining yourself to individual services or service groups. So the notification is received in our simple queue service. We have an application running on top of EC2, which is in scope for compliance, that is listening to that queue and waiting to react, to be able to update patient information, to be able to add new patients to the system, and that is in scope for compliance for dealing with that personal health information. DynamoDB is also in scope for HIPAA. And so we can read that information in EC2. We can enrich it with patient information from other systems that we're connected to, and ultimately store that in DynamoDB along with the status updates that may be relevant. Once it's in Dynamo, we're then able to expose it to our web applications and other applications where we can authenticate the user and expose that information to healthcare professionals who need to have access to it. And this is exactly how we operate today. Many hospices, certainly ones that I've come across, are using digitized systems. They have access to patient information from their PCs and are able to look up these patient records. This is workflows that's already happening. Great. So as I said, the strategy here really is drawing the line between what is in scope for PHI or for HIPAA and other compliance standards, and being able to separate that information out in your application so we can use all of the services available to drive better outcomes for patients. So the second half of my talk is about exposing that information in a helpful way. How do we enable new interfaces, hands-free, interfaces that aren't bound with typical web or mobile? And the short answer here is the Echo platform and using Amazon Alexa to bring voice capabilities to our own applications and our own data. So the example I'd like to use here is from the Boston Children's Hospital. They have an innovation and digital health accelerator, and they developed an Alexa skill to help parents find out crucial information for their children's care. For those who aren't familiar with Boston Children's Hospital, they're a cutting-edge pediatric institution in the States, paired with Harvard Medical. And as I said, their full session's available online, so if anyone is interested in seeing the use case and hearing directly from the guys at the hospital, I'd be happy to forward that through to you after the session. So what problems were they trying to solve here? So from the research that they conducted, parents are using the internet already to find answers to common health questions. And all of us who use the internet know that that information can be a little bit spotty or unreliable. And ultimately, we want to be able to provide good quality advice just in time to be able to help parents managing their kids' health derive better outcomes in their interactions. So the quote really here is, although I will always go with my gut about my kids, I do go to the internet to confirm my suspicions. And this was a common finding. I think the full consumer research is also available. They had a group of 200 that they surveyed. So this is common enough that the chap at the kids hospital wanted to create an Alexa skill to expose curated medical information to parents through the Alexa platform. Ultimately, this manifests as a voice interface where you can ask KidsMD questions about common sicknesses. The demo presented used fever as a good example. So ask KidsMD about fever. And using the voice flows, they were able to ask a set of follow-up questions, provide information from a reliable source, and ultimately determine, for example, whether kids need to come in for inpatient care or whether it's mild enough to be within regular tolerances. And so really what I wanted to do was give you a way to use this information, to build your own Alexa skills. And as I said, it really is an afternoon's job for a hacker. I'm not even a real developer. So hopefully what I'll go through next gives you the ability to implement some of what we've talked about in your own applications and your own organizations. So what is an Alexa skill? So Skills is the platform that we provide to extend the capabilities of Alexa. Think of them as apps in the Alexa world. Examples here might be takeaway restaurants, giving you an interface to order your favorite takeaways, or cab and car hire organizations giving you a voice-enabled endpoint to ask for a cab, or as we saw in the case of KidsMD, a place to ask for health information without having to go to devices and use search engines. So there's two parts that make up an Alexa skill. First is the configuration information that's done through the Alexa development portal. That's also the interface you register your skill publicly. But long before you register your skill to be used by the general public, you're able to demo it and to develop it in a sandboxed environment where it's only available on your own Alexa devices. The second half is a hosted service that sits behind the Alexa platform that actually provides the information that you're looking to provide. So this might be an API endpoint that already exists. So if you've built mobile applications doing these, providing this kind of information or providing interfaces to your applications, those APIs can be addressed directly. Otherwise, we'll talk a little bit through a few examples of building these hosted services on AWS from scratch to help you guys get going. And so what happens when we ask Alexa something? Well, the first thing that happens is Okay, sorry. What happens, how does the design process begin from scratch? So we go along to the Alexa development portal, we introduce our application, we give it a name, we describe our intents. So the idea here with an intent is, what are the types of questions people will ask? What are the realms that I want my app to do? So for us, the intent might be get advice about fever, or get a cab, or order pizza. We describe these in a format that allows us to catch common examples of that question. There's a few ways I can talk about ordering a cab. There's a few ways that I can talk about high temperatures or fevers. And we describe those as intents in the Alexa skills portal, so that Alexa has a wide range of mappings, essentially, she can do to route the user to the right place. So when a user is looking to ask Alexa questions, the first thing Alexa does is record the user audio and upload it to the Alexa service. This is done in real time. There's almost no delay. And the Alexa service uses machine learning and natural language processing to infer from that audio file what the intent the user actually has, and maps it back to the intents that you've described that correspond to the functionality you're exposing in your app. The user intents and arguments are sent straight through to your backend service, where you have mapped applications, databases, and functions to fulfill those intents. So as I said, that's the point at which the Alexa service is calling your endpoint, your APIs, giving you the information that somebody is asking about fever. We also give you access to a session token describing who the individual is, and where they are in your overall design flow. So if you want to ask follow-up questions and similar activities, you're able to see where your user is in your flow. A text response is typically sent back from your backend. So that's, I've looked up the answer, here it is, Alexa. That usually includes a direct text response to send for Alexa to voice out to the end user. That may also include card information. So Alexa comes with a companion app, and it gives you the ability to send images or longer text information to the companion app to elaborate on the text that Alexa is saying. So again, lots of examples of what this might be. It might be drug recommendations of as you would find on the back of a drug packet. It might be further instructions or a link to websites for checking availability, that kind of thing. That can be sent to the companion app to enable the user to learn more or to get more from the answer that they've asked for. You're also able to send audio responses back. So if you did want to play audio to the end user that is your own, that is custom, again, we give you the interface to do that directly through Alexa, so you aren't limited just to a text response. And those audio responses are rendered back on the device. Great. And as I mentioned, Alexa has the companion app. So while the answer is being set out on the device, you can also include find out more on the companion app. And users at that point are invited to go to their apps and to see the extended or the elaborated information that you're providing back to them. Great. So what did the KidsMD skill look like? We mentioned the two halves, so the Alexa service that's handling the audio, the speech-to-text generation, and then the natural language processing to understand the intents. But after Alexa has determined what it is your end user is looking to do or what information they're looking for, it goes directly to your backend to deal with that. So one of the options we have with Alexa is binding that functionality to a Lambda function. So what we're able to do with Lambda is sit in between our services and the Alexa service to apply custom logic. In this case, the KidsMD app is using that to infer from the intents which of their backend APIs is relevant to be called, whether we're looking for fever or we're looking for drug recommendations or other information. And it uses this to determine which backend service that they already have existing should be called. So Lambda in this case is being used as the glue in between the Alexa service and their existing backend systems. They actually chose to implement their existing backend systems using AWS services. So API Gateway, which is responsible for hosting their API endpoints. API Gateway is also a pay-as-you-go model. So similar to Lambda, if nobody's calling your API endpoints, you're not paying for it. which is absolutely fantastic. They also chose to implement the core of their application on EC2 using RDS, our relational database service, as the backend information store, and then storing other objects in S3. That might be pictures or graphics that they want to render in their companion app. And so we can see how the Alexa service and the Alexa platform plays nicely with the AWS backend to build these full-stack voice-enabled applications. Cool. So what are our considerations? What should we be thinking about when we're building Alexa skills? So the first is, how are we guiding our users through the application? Although it's fun to build sort of general question apps or very simple applications on Alexa, the platform allows you to build very rich conversational environments to be able to guide users through a state machine. And so think ahead of time on what your states would be, what your user journey or user path might be, and how you're going to represent that as nodes in a decision tree. Decision trees are only one option here, and for those of you with a keen eye on our roadmap, you may have seen our Lex service that we've pre-announced. Lex is a machine learning-backed conversational engine. Allows you to build things like chatbots, but eventually you'll be able to use Lex to, instead of predetermining decision trees, to actually, in real time, using machine learning practices, respond to conversations or respond to questions without having to predetermine them. But for now, customers are using these decision trees to confine the realm that their customers can ask questions in and to guide them through things like follow-up questions, clarification questions, retries, and ultimately to expose the intents that they are providing skills for. This is just an example of a decision tree and a set of decision nodes in the Node.js language. You're free to develop the backends in any language. If you're using Lambda, supported ones currently are Python, Node, Java, and most recently announced C#. So if there are any .NET or Microsoft developers in the house, hopefully that's great news. Cool. The next consideration is managing context. So how do we manage the session information about my current invocation of an Alexa skill? So how do I manage who I'm speaking to, where I should be sending responses to, and how far through my flow they are, what state the device is in. So we provide you a session object. It gives you a session token for the duration of your skill. So if it's a very simple question answer, that session token is likely to be very short, but these persist for the entire question or the entire interaction between your skill and the end user, which allows you to put in session information to inject in context that you can use in your application to guide your user through and to store their current state through your application's journey. This also gives you access to the user information, their application information, and a few other useful bits. And again, customers are using DynamoDB here for longer-lasting session information. If you are maintaining context across a number of interactions, for example, in the KidsMD use case, this might be tracking an individual child's temperature over a period of time. Alexa, tell KidsMD the temperature has gone up 10 degrees. Storing that session information in Dynamo allows it to persist outside of the realm of an individual session for you to use in future contexts. Which is really, really powerful. Think about the slot types. So these are existing data structures and data formats that Alexa understands and can speak in a format that's natural for that function. So dates, times, there's examples here with first names, both British first names and American first names. Information where the Alexa service already contains the phonetic information on how to pronounce and how to, what format to say those particular bytes of information in. The cool thing here is you can extend the slot types. So if this is particularly relevant in the medical space where nobody can pronounce the drug names and the, and the conditions, you're able to create custom slot types and to define those phonetic expressions, the pauses to be used, the inflections, in a way that allows you to bring new words or words that Alexa doesn't say or can't say out of the box. Great. Using the speech synthesis markup language, you're able to change the way that Alexa is speaking your text, putting in pauses, putting in inflections, and other aspects. This is great for reading out things like serial numbers or phone numbers where you want to put breaks in for the user to actually write down an act. So again, it gives you full control on the voice, the output, and the voice interface that you're working with to be able to shape it to better fit the use case. So here's a few examples of what the markup language looks like. For those who have written HTML in the past, you can see it's a fairly similar, it's sort of loosely XML based. And so, yeah, being able to use the markup language to enrich the voice that's being rendered by the Alexa service allows you to be more expressive in your voice applications. Cool. So using the markup language, I think we've already sort of mentioned that there is a lot of medical terminology that isn't used in general conversation. So being able to write expressions for those particular nuances in the field allows you to write things that your end users will be able to identify with and be able to understand. It also acts as a nice translation layer between doctors and medical professionals and the rest of us. Cool. So again, this is an example of how you'd use the phonetic alphabet and the phonetic utterances to build words that wouldn't otherwise be in a standard dictionary. And you can test these out. So there are a few interfaces for testing Alexa and testing Echo without actually owning a physical device. There's a great online Echo Sim that allows you to bind Echo Sim to your development skill and to try the voice interface without actually having to have the hardware. So again, if you are planning to go away on a Friday afternoon and hack with Alexa, I recommend taking a look at Echo Sim and playing with the representations, the phonetic representations, and all of the other features available for crafting sound in the Alexa platform. Cool. And then again, for us to improve the operational aspects of our application, we may look to logging and monitoring solutions to monitor the performance, the number of invocations of the backend Lambda functions, the number of questions being asked to the Alexa skill and platform, and custom error logs. Can we catch words or utterances that users are making that don't match the intents we already have to drive improvements in the voice interface? All of this can be done using CloudWatch. So out of the box, Lambda presents all of its logs and errors into CloudWatch logs for you to retrieve and to review. We can drive events off of those. So in real time, if we want to be alerted to utterances and invocations that don't match with our intents, that aren't being caught correctly by Lambda and being forwarded onto backend APIs, we can use logging, auditing, and monitoring to improve over time the voice interfaces and to include those utterances that are being used that we hadn't thought of beforehand. It also gives us a place to audit interactions, so to view essentially a transcript of what happened, what conversations went on. And this is super important not only for healthcare professionals, but also for long-term care and monitoring the questions that are being asked and the answers that are being given. Great. We also have the ability in Alexa to bind users in your system to users on the Alexa platform. So everyone with an Echo has a unique identity. By default, that's not bound to anything other than their Amazon ID. We can provide that identity to you to link in your backend user systems. If you're already using a user database, if you're already keeping track of the people using your applications and using your platform, knowing which is their Alexa device and being able to use that ID to authenticate users is truly powerful. And so I wanted to make it clear that that functionality exists, that you're able to manage users and user information on the platform. As I mentioned, I am aware that I'm keeping you guys from lunch, so this really is the last couple of slides. I mentioned very briefly that we can display other forms of information through the Alexa platform. So using the companion app or by forwarding audio, MP3 audio directly through the device, we can play sounds and speech that we've generated through the Alexa platform directly. We're also able to show images and web pages and links and other sort of rich media formats through the Alexa app to better help our users. Great. So here's an example of the KidsMD companion app. A question was asked about coughing. My child is coughing. What should I do? The app gives general advice through a voice interface and says if you'd like to read more, take a look at the companion app where you get a full description of that behavior, of common symptoms that are associated with coughing and others. So what have we gone through today? Well, the first thing we looked at was the IoT service. We saw how easy it was to manage millions and potentially billions of things on the platform to be able to connect information that's suitable or that's relevant for healthcare applications. We then went on to have a look at using Alexa to bring intuitive voice interfaces to those applications. We've seen how users can interface with Alexa to get good advice quickly without having to trawl the internet and the risk that entails. What we haven't considered and what I would consider you to investigate is the accessibility options that this brings to your end users. The ability to bring voice applications to those who can't use more traditional mobile or web-based media interfaces. And the last thing is building Alexa skills is fast, fun, and can be very rewarding for patient outcomes.